Hello students, today we will start with chapter Matrices. So Maths 1, chapter number 2, Matrices. We had started with chapter number 2, Matrices, as this topic will be easy for you to understand. So what is matrices or matrix? We say matrix in singular form and matrices in plural form. So now what is matrix? Matrix is rectangular arrangement of mn numbers in m number of rows and n number of column. This definition of matrix you had studied in 11th standard. So what is matrix? Matrix is rectangular arrangement of mn numbers in m number of rows and n number of columns. Example, suppose it is matrix A. You all know matrix are written, element of matrix are written in rectangular brackets. So suppose A, B, C, D, these are 4 elements of matrix, 4 element. So first row, second row, first column, second column, that is 2 rows and 2 columns. So it is rectangular arrangement of 4 numbers in 2 rows and 2 column. One more example. Again, this is rectangular arrangement of 6 numbers in 2 row and 3 column. 2 row and 3 column. First we will write for row and second we will write for the column. So it is nothing but rectangular arrangement of 6 numbers in 2 row and 3 column. So what is matrix? Matrix is rectangular arrangement of mn numbers in m number of rows and n number of columns. You all know this definition of matrix, as you know, as you had studied in 11th standard, and also in the 11th standard we had studied the type of matrices and the algebra of matrices, like how to add the 2 matrix or subtract the 2 matrix or the multiplication between 2 matrix. So these all topics you had studied in the 11th standard. Now we will proceed further. So the next topic is elementary transformation. You all know the basics of the matrices, like type of matrices, addition, subtraction or multiplication. So we can proceed further, like next topic is elementary transformation. So what is elementary transformation? So elementary transformations are the 6 operation. Okay, so elementary transformation, the elementary transformations are the 6 operations, 3 due to row and 3 due to column. This elementary transformation is basically used to find the inverse of matrix. So elementary transformation have 6 operations, 3 due to row and 3 due to column. So first we will say, see, A, interchange of any 2 rows or any 2 column. So interchange of any 2 rows and any 2 column. What is that? Ri interchanges with Rj. That means what? Ith row and jth row are interchanged with each other. So when we will go for the exercise, you can this topic will be more clear to you. So Ri interchanges with Rj, that means ith row and jth row are interchanging with each other. like R1 interchanges with R2. That means what? Row 1 and row 2 are interchanging. Similarly, for the column, Ci interchanges with Cj. That means ith column interchanges with jth column. We see one example. Suppose this is matrix A and here are element A, B, C, D, E, F. If you apply R1 interchanges with R2, if you apply this, so new matrix will be R1, that means row 1, R2 that means row 2, both will interchange. That means row 2 will go to the position of row 1 and row 1 will go to the position of row 2. So this is interchange of any two row. Now similarly we see interchange of any two columns. Suppose again this is matrix A, B, C, D, E, F. So we applying C2 interchanges with C3. That means what we want? Column 2 and column 3 to be interchanged. So column 1 will be as it is. Now in the place of column 2 we will write column 3 and in the place of column 3 we will write the element of column 2. So this is interchange of row and this is interchange of column. I hope you will understand with this example more clearly, that is what is interchange of rows and interchange of column. So elementary transformation, there are 6 elementary transformations, 3 due to row and 3 due to column. So we had studied 2 elementary transformation, 1 due to row and 1 due to column, that is interchange of any two row and interchange of any two column. So we had studied 2 elementary transformation here. Now next